Welcome to the education classroom. Learn with clarity, understand every concept, and achieve success in your exams. Let's start learning.
To understand a population, researchers collect thousands of individual results. But looking at these isolated data points rarely reveals a clear pattern. The challenge lies in finding a single representative value that accurately summarizes how the group performed as a whole. This requires a statistical concept called central tendency. It provides a method for identifying a central position within a distribution to represent the entire dataset. Statisticians use three distinct tools to locate this center: the mean, the median, and the mode. Applying these measures allows researchers to characterize the performance of a large population using a single descriptive summary. The mean is the arithmetic average. It serves as the mathematical balance point for a set of numbers. The formula is straightforward. Sum every individual value in the set, then divide that total by the number of observations. With a frequency distribution, each value is multiplied by its frequency before the results are summed and divided. In a symmetrical dataset, the mean provides an accurate center, balancing evenly. But the balance shifts the moment we introduce an extreme outlier, a value significantly higher or lower than the group. Because the mean incorporates every value into its calculation, it is easily pulled towards these extremes. This results in an average that no longer reflects the typical experience of the group. When a distribution is skewed by these outliers, the mean becomes an unreliable representative, leading statisticians to use measures that ignore extreme values. This text describes the median, which identifies the positional center of a dataset. It is specifically used for skewed distributions because it is not affected by outliers. To find the median, the raw data must be arranged in order of magnitude. The median is simply the middle value, separating the higher half from the lower half. If the dataset has an even number of observations, the median is the average of the two middle numbers. The third measure is the mode, which is defined as the value that appears most frequently in a dataset. As detailed here, the mode is uniquely capable of summarizing nominal or categorical data, such as identifying the most common car model or the most frequent brand preference. A dataset can also be bimodal or multimodal, meaning it has two or more values that occur with the same highest frequency. While the mean provides a mathematical average, the median and mode describe where the data actually clusters. The specific distribution of the numbers determines which tool is most appropriate to use. The relationship between these three measures depends on the visual shape of the data distribution. This chart shows a normal, bell-shaped curve. Because the data is perfectly symmetrical, the mean, median, and mode are located at the exact same point. In a skewed distribution, these values separate. The mean is always pulled furthest toward the tail, while the median stays closer to the main body. In a moderately skewed distribution, the three measures are linked by this empirical formula. The mode is equal to 3 times the median minus 2 times the mean. A common way to distinguish these tools is by their function. The mean is the average, the median is the middle, and the mode is most frequent. In fields like educational research, selecting the right measure allows for a more accurate comparison of class scores or student performance. By applying these different measures of central tendency, statisticians can accurately describe the typical experience of a group, even when the underlying data is complex or unevenly distributed.